All right, I guess we're recording now. The mandatory phrase to be said at the start of every, oh, I guess we're live now. Wait, is this thing on? Hello, everyone. And thank you, Owen, for inviting me along for the first go. I took you very literally when you said that this was going to be a casual presentation. So here's my presentation. It's 5 bullet points written on a piece of paper uh, that I'm going to talk about. Just a little bit of kind of general background. So I actually did my PhD in computer science, specifically in like analysis of algorithms and thinking about running times. So this is a topic that is dear to my heart that I could go extremely deep in, uh, but will not be going that deep in tonight. But that's sort of the motivation for this. As it is, I'm aiming for 15 minutes, so I've got like 5 roughly independent topics that I'm just going to kind of touch on briefly once each. So just, I mean, the general kind of principle of this is, I think most people, most of the time, don't have to give a lot of thought to calc efficiency in Excel because Excel is pretty fast and modern computers are pretty fast, and things just kind of work. Until sometimes they don't, when you've got an enormous file and it takes 5 minutes to recalculate every time you kind of move your mouse from one side of the screen to the other or something like that. The challenge, of course, is that once you're that far in, it's quite a big task to unravel everything. But I'm going to talk about a few things that might help you avoid getting to that place in the first place. The one kind of thing to keep in mind is think about, so like computer scientists are always thinking about algorithmic complexity, which is basically a fancy way of saying as the input scales, how quickly does the running time of the algorithm scale? So for example, if you have a list of 4 items that you want to sort and you just compare the first 2 to each other, put them in order, then take the next one, compare it to the biggest thing, then the next thing, the next thing, the next thing, and keep doing that until you've placed each thing in the right place, that works fine for 4 items, but if you do it for 10 million items, it will run until the cows come home. Or, to be more scientific about it, it has O of n squared complexity, meaning that how long it takes will be roughly proportional to the square of the number of elements, which means that if your number of elements gets large, the square of it gets very large, and it gives you problems. If you have an efficient sorting algorithm, then it can run in O of n log n time, which, if you don't know logs, you don't need to worry about that, but let's just say it's much, much faster. And that's as good as you can do for a general comparison-based sorting algorithm. But so what are some parallels in Excel land? I'm going to start with 2 of the more obvious ones. One is I see people all the time doing like the ultimate authoritative, timing comparison of VLOOKUP versus XLOOKUP versus index match. I would say don't worry too much about that, but if you have a situation where you're looking up, let's say, 10 or 50 different pieces of information on the same record, then it will make a pretty big difference in terms of calc time if you're doing 50 independent lookups for that. So I see this all the time where there's like a big table with employee data, 50 different fields in there. I see Win on here, no doubt thinking to himself, well, yeah, but just Power Query. Why would you do this with formulas at all? Which is, of course, the more scalable solution. But before you get there, if you want to pull out 50, like let's say you've got a subset of employees that you're interested in, just the people in a region, just the people in a team, whatever, the people that you're thinking about promoting, the people you're thinking about restructuring, whatever it is, but you want to populate a whole bunch of information from many of these columns from your big general HR file. So if you do that, as I see people do all the time, by doing a lookup for each item for each person, then just think about it very simplistically. If there's 50 columns, it means you have to do 50 lookups for each person. Now, if you replace that with 50 index matches, it's not going to change the speed greatly. But if you replace that with 1 match to get the row number, and then 50 indexes that just say, go to row 50, it's right there, that's going to be much, much faster, because the hard work is not, it's not figuring out like what's in cell A50. That's really quick. The hard work is figuring out where in this 50,000 rows do I find the match? So like one match and 50 indexes, or if you're returning consecutive columns and you have modern Excel, one XLOOKUP returning from the whole range is going to be much, much more efficient than having 50 different lookups. So that's one. Another one, semi-related, not totally related, is just Charles Williams, the fast Excel guy, whose website I think is fastexcel.com or fast something like that anyway. But if you just search Charles Williams fast Excel, you'll find him. He is like the godfather of efficiency in Excel, and writes all kinds of super efficient add-ins and functions and things for Excel, and knows more about this stuff than the next 3 people put together, I would guess. But he had this really interesting counterintuitive thing back in the days when VLOOKUP was more popular and less problematic than it is now, which is that if you have sorted data, that you'd be much more efficient to use 2 range VLOOKUPs than 1 exact VLOOKUP. The logic being, you don't want to use a range VLOOKUP if you're looking for an exact match, because then if your thing isn't in there, it will fall back to the next lower thing and it'll say there's a match when there's not. But his proposal was basically you do 1 range lookup just on the first column, returning from the first column, look the value up, return the next match, and if that matches, then you do a second lookup to get from the first column to the second column. Seems a little counterintuitive to say, well, okay, but then you're doing 1 lookup to see if it's there and then a second lookup to get the answer. But because you're doing a lookup that's based on the assumption of sorted data, it makes it much, much faster. So if you think about, how long does it take you to find a name in a phone book? 30 seconds. How long does it take you to find a name in a book with 30,000 names that are listed in random order? A very, very long time. So like the general exact match VLOOKUP that does not require data to be sorted, because it doesn't require that, is massively slower, because its job is much harder. It has to look, like if there are 10,000 rows, it has to look in every one of the 10,000 rows. Whereas if you have sorted data and you just need to know the nearest match, then you can just do a binary search, like look in the middle, and that'll tell you if you're looking in this half or this half. And you've immediately, in one comparison, you've cut the search space in half. And so you do that, whatever, 10 times, and you've cut the search space into 1,000th. It's going to be much, much, much faster. So there are lots of things where, sorting your data and then, hopefully then also adding an integrity check to make sure that your data is sorted and throwing, an alert if it's not. But sorting your data and then running a formula that efficiently uses the fact that it's sorted will make it run a lot faster. All right, that's 2. Number 3 is about volatile functions. So there are a set of functions like offset, indirect, now, today, rand, I don't know, there's a few others that are volatile functions in Excel. You may have heard these just kind of used as a general bad word. There's a lot of people who are of the sort of opinion that you should just ban them completely, never ever use them. I'm not nearly as strict about it as that, because I do think they can be quite helpful, but it's useful to understand a little bit about how they work. So the idea is, if there are, a billion different calculations going on in your spreadsheet because you've got, tens of thousands of rows and hundreds of columns and whatever, Excel is very, very smart about figuring out, okay, you just changed one thing. There are only actually 5 cells that are downstream of that. I'm going to recalc those 5 cells and we're done. We're good here. Or if you have calculation turned off, it will flag those 5 cells as it's called dirtying the cells, meaning those will have to be revisited next time there's a recalc. But if you go into manual calculation mode, make a handful of changes, and then go back out of it, it doesn't recalculate the entire workbook because it doesn't need to. It keeps tabs of what you're changing. So the issue with volatile functions is that it makes it hard for Excel to tell what you're changing. So like with offset or with indirect, like it doesn't work, for example, with the trace precedence, trace dependence arrows for formula auditing. And that same sort of logic that helps it figure out, okay, is something referring to this cell, breaks if the reference is coming from an indirect or coming from an offset or coming from one of these other volatile functions. And so what that means is that anything, like it never knows if that particular function is clean or dirty, and so it always recalculates that particular function, but it also then has to recalculate anything that is downstream of that. So the downstream is really important, because if you're using an offset or an indirect in like one place toward the end of your workings, like, let's say you've got a company model with 50 different business units on 50 different tabs, and you use an indirect to pull a specific business unit for a report, and you can switch between the business units. That's not that big a deal, because all your main calculations are upstream of that, and they're not all going to be recalced. But your sort of worst case scenario is, let's say you have a set of assumptions, and then you have 3 different versions of those for 3 different scenarios. If you choose your active scenario by using an offset, then every single thing that depends on any of those assumptions will be permanently dirty, permanently recalculating. Every time you kind of touch anything in your model, it'll run those forever. All right, that's number 3. I got 2 more to do, and I think I'm already over time, or over target amount of time, toward my 15 minutes. So 2 other things. One is associated with again, another kind of Charles Williams thing that a lot of people have not heard of, but I've just been talking to people about recently, is the concept of short circuiting. So it's sometimes very relevant to know, in a function that makes a decision about which branch, meaning an if, an ifs, a switch, a choose, is Excel evaluating the branch that you think it is, or is it evaluating the whole thing? Seems like it should be obvious, but it's actually not. So if you say, if this check, then do this huge calculation, otherwise blank. So like, for example, in large workbooks, I often have a sheet by sheet selector to activate or deactivate the sheet. Like, is this sheet active? And then every formula on the sheet can say, if this sheet is active, make this calculation, otherwise return an empty string, or otherwise return inactive, or whatever. And if does what's called short circuiting, meaning if you say if true, it'll calculate the true branch, but not calculate the false branch. And if you say if false, it'll calculate the false branch, but not calculate the true branch, which means that if you have a whole bunch of calculations going on here, but only in one side of the if, and you switch to the other side, none of that calculation happens. And so if you have a bunch of kind of intensive workings that are, say, specific to an output that you're not looking at most of the time, you can switch those off if you use if. If you use other functions that seem logically like they should behave the same way, they don't necessarily. So if behaves that way, and I think the other one that does is choose, but ifs, the newer one, does not. It evaluates every piece of it. So if you have like ifs, simple condition, simple result, otherwise complex calculation, it's going to do the complex calculation whether the condition is met or not. And the same goes for switch. And the other one, to my great sorrow, because it's my favorite function, that does it, is let. So again, if you have a series of kind of complex calculations, but then you have a check at the end to say, well, we're only going to use all these complex calculations in one scenario, but not in another, bad luck. Let's going to run all that calculation anyway. So it's worth thinking a bit about how you structure your if and your let. In other words, if there's a short circuit scenario, do an if up front to say, if your short circuit condition is met, give your simple answer. Otherwise, do your whole big let. It might mean that you have to nest an if in a let and another let inside the if it's a really complex calculation, but efficiency-wise, that could make a very, very big difference. Again, it depends on how often it's going to be switched off and that kind of thing. But if you want to be able to do that, it's important to understand how those work. I saw someone posted Win, thank you, posted a link to Charles Williams' site on that, which is a great place to read about it. Last thing I'm going to mention is the ability to time functions. So as you think about, which of these different methods that I might use is more efficient or scales better as I go from 10 inputs to 10,000 inputs. Super helpful thing. Again, Charles has a thing on his website for some simple VBA code that's great for timing. That's great for timing either whole workbook calculation, recalculation, sheet calculation. There's all kinds of different settings in there. But if you want to time like one complex formula calculation, which again is increasingly common now that lets you do more and more stuff in single cell or with one spilling dynamic array to generate a whole report or to do a whole lot of work. The steps in let are evaluated in order from start to end. And so if you have a call to now at one step and a call to now at another step and 5 seconds of calculation in between, those two calls to now will return times that are 5 seconds apart. And so it's quite simple if you have a big single formula that you want to time to say, let start time be now, calculation be your whole formula, end time be now, and then you can return the end time minus start time formatted however you want. It doesn't give the exact same result every time, but the kind of calculation limit on the accuracy is I think 100th of a second. If you have something that's like this runs in less than 100th of a second, so it just looks like 0, but I'm going to have it 10,000 times, then you can use something like map or biro or bycall to run that calculation 10,000 times and see how long that takes, so that you can see, okay, with option 1, running it 10,000 times takes 0.2 seconds. With option 2, running it 10,000 times takes 8 seconds. Great. Well, if it's that big a difference, it would probably be obvious without that, but you get the idea. That's it. That's my 5 topics.
Thank you. That was enlightening. I feel like you've run through so many complex topics in such a short time. I'm sure there's a load of stuff that everyone can take away from that. And since I have a habit of forgetting a lot of things, a lot of that was either new to me or a good reminder. So I truly appreciate that. I've noticed we've got a few more people joined. Cristiano, Celia, Matthew, everybody, welcome. Eric, thank you for coming. That was Dim. He presented on formula efficiency, and I did pad the time so that if people go over 15 minutes, we're still okay. That was
I spent years as a competitive debater in university, and if you went over 7 minutes, you started getting penalized. So
well, there's
no keeping to time.
There will be no penalties here, not for this meeting anyway. Maybe in the future. And with that, can we just scan through a couple of the questions that people had before we move on? Are dynamic arrays faster? Does it make sense to return an array when doing a lookup across several contiguous references? From Jose.
So I would say yes for that one. I don't think it would be massively different than doing the kind of one match and many indexes, but it would be much better than doing 50 separate lookups, with a slight caveat that I think there is some sort of clever like caching going on under the hood with lookups these days in Excel. So I don't think it's quite as bad as 50 lookups of the same value in the same table will take 50 times longer. But I do think it's still the case that it will take longer than doing, one match or one lookup returning 50 columns. So definitely prefer that option. But it might not be quite as clean a story as when I started telling that story. Named ranges or table with pivot by or group by? Yes to all of these things. I'm not totally sure what the question is, but I'm in favor of all of those things.
I would say writing it to write a group by formula is easier with a structured reference. It's easier with a table than it is with a named range, because a named range, it has a name, but only for the object itself. It doesn't have a name for each of the columns within the object. That's just my opinion.
I don't know like how people's minds work on this in general, because like some people really seem to not find structured references intuitive. I find them super intuitive. But like lots of smart people who know a lot about Excel and financial modeling and can wrap their heads around tricky concepts still seem to say this looks weird to me. So don't know. Choose your poison, I guess. Is conditional formatting as heavy as people claim it to be? I've never had any major issues with conditional formatting. Um, I mean, you can put sort of arbitrarily complex formulas in conditional formatting, and they do have to be evaluated every time the thing is rendered. And I guess if you put something volatile in there, that could be a problem. I will say I do not infrequently put an an offset in conditional formatting where I want to have like a line to separate on a change of section, like where we're going from category A to category B, because you can write it as, if this value is different from the value in the row below, then blah, blah, blah. But then anytime someone inserts a row in that table, you've got different conditional formatting rules, some of them pointing 2 rows down or 50 rows down, and some of them pointing 1 row down, and it makes your rules a bit of a mess. So I regularly use a rule that says, if the value in column F is different from the offset from the value in column F by 1 row, then do something. I've never had any performance issues with that. But like I said, you can put super complex formulas in conditional formatting, and then I guess you could have problems just like if you put them anywhere else.
So there was some clarification below saying, does creating a table help Excel query or filter data faster?
I don't think so. The only time I remember it being an issue for me was a particularly ginormous model and this was more than 10 years ago that I built it. I built the model using tables for everything because I wanted it to be more flexible as things grew. And then I did notice that was, for whatever reason, I'm not totally sure why, but that was running slower. So I ended up detabling everything before I handed it over because it made it run noticeably faster. But that was a particularly, like, today, or most of the time since, I would have had large chunks of that workings going on in Power Query rather than in formulas, so that it wouldn't be so slow in the first place. But I didn't know Power Query back then, so yeah, I did notice a performance change, but only in a relatively extreme situation, and that was a performance change that was a negative 2 tables.
Okay. And there's one more question. I'm not sure I understand it though. So is
Is there
from
a way to
Will.
distribute a value across a conditional function? Example, if 8 plus value is greater than 12, 8 plus value, otherwise 8 minus value. I'm also not sure I understand what is being asked here. To distribute a value across a conditional. Oh, sorry, I got you. So I think the question is, if you have value in 3 different places here, can you avoid having to recalculate it in all these different places? And if that's the question, then I think the answer is you can do that with let. So you can define the value once at the start by saying let value be big complicated calculation. Then if value is this, do that. If value is this, do that. If value is this, do that. Whatever else you need to do.
That makes sense. Now that you put it that way. Okay.
Oh, and I think you've gone on mute.
That was the last question, and Matthew makes a good point that you can put the value in a cell and reference it, which is of course similar to creating a let variable. So that's great. Thank you so much, Dim, for answering those and for teaching us about formula efficiency. Appreciate it. We are going to move on to our next honored guest. I'm going to hand over the presentation now to Aditya.
Owen, and hello everyone. So yeah, thank you for inviting me, and it means a lot to share the same stage as of my masters. So it was like exciting for me as well. And coming to the point of the way the structured data types in Power Query, yeah, right. So in Power Query, so if I'm being honest, I'm not a programmer. Mostly, I am from accounting or you can say finance background. So, and my day-to-day life is going with Excel. So what happened was when I got into Power Query, so I started thinking from the perspective of an Excel user. Okay. So it created me challenges because the first time I was seeing the list, records and everything. So I will give a disclaimer as well. So in this session, I am not going to share more about how to create a record or how to access the fields and everything. I will be just sharing more about the difference between a record and a list. Okay. And if you are excited to learn more about how are records created, what are the brackets available in Power Query, then what you can do is you can go through this post of mine. So there I have actually discussed more about the whole thing. Okay, how many types of brackets are there and what is the meaning of each of the bracket. Okay, sometimes they are to create a record and sometimes they are to access the field of a record. Got it? So it confuses me initially because in normally in Excel we are just using with the uh, curly brackets for arrays and you can say that the normal parenthesis for our day-to-day calculation. But it was hilarious when it comes to Power Query, and I couldn't understand because I started learning Power Query, you can say in 2020, but I got no clue till 2023. So it didn't make me sense. So later, what I did is it was you can say that when I started learning actually Japanese. So how can I tell you in proper way that normally none of my family members or no one in my locality speak or learn about Japanese. Japanese was for me more about watching animes, Japanese animes. So that's why I thought, okay, let's go and learn Japanese anime. And in the first 6 months, I was like, wow, I can nail it down and I can learn Japanese. Only to figure out there are three scripting languages: hiragana, katakana, and you can say kanji. And now what happens is that each of the words, I can understand the words, but the thing is that how to pronounce them and what are vowels and what are consonants. So it was getting challenging. So then I took a pause and then I thought, okay, what is the problem going on, right? So even if you play games, you can directly learn the combos, but you if you don't understand how the skills will work, so it will create problems. Why I'm giving you these many examples, that's the way I actually faced the problem, because I couldn't understand what are records, what are lists, and okay, I understand the text functions and calculations and everything, so it didn't make me sense back then. So then I thought of, okay, why not start building step by step and learn first about the structured data types. And then I thought, okay, yeah, that's the way I can now understand Power Query better. And that one of the analogies I got later on in my life, and that analogy is now helping me when I'm working with Power Automate web version, where JSON is there, and again the list and records are there as well. And when I started learning recently about Python, so in Python again there is list, there is dictionary, there is you can say tables, that is metrics, data frame, or anything you want to say. So now because I know about records and lists, so you can get the idea they are actually prevalent everywhere in every programming language. So let me share you one of the stories. You can relate it and then can understand the difference between a record and a list. So I am going to take the Doraemon's time travel machine and taking you back before 2014, at least in India. So we didn't had that kind of speed internet. Now we are using Spotify and you can say Ghana.com. But earlier, if we wanted to purchase any DVD for the movies or you can say songs, we used to go for stores. Okay. So let's say I wanted to, I am a big fan of Taylor Swift. So I wanted to buy Bad Blood song of Taylor Swift. So I went into the store and asked the shopkeeper where I can find the song. Okay. So now what the shopkeeper is saying me, Aditya, just go to the 2014 area. That is the year name. There you will find a shelf that will have the name of Taylor Swift. And then you can do is you can have one of the rack there, which will mention about the album name that is 1989 if I'm correct. And then you will find the song Bad Blood. Okay. So what is happening is he is clearly guiding me the way. Okay, Aditya, what you can do is you can find the first American country singer named Taylor Swift, and then you can say the album name, and then finally the song name. But what happens when it comes to list? So I will tell you what will happen. So now the person is saying is across the shop you will find the last shelf. Okay, in the last shelf you will find the third you can say the last area, the third rack, and in the third rank you can say that second from the last that second. So in a way what I simply mean is there you come to the concept of indexing. Okay, so instead of juggling through the technical words, what I will do is I will share my screen and you can get the idea this way. One second. Okay, it is sharing wrong screen. Yeah, yeah, you can see, right? So this is normally a record. So now you can see that these are some of the information of people whom I wanted to get. Okay, so if I just want to get information of Emma Watson, so what I'm going to do is I am simply writing Emma Watson, right? And you can see that instantly I get information of Emma Watson. And if I am interested getting her country, so I can come here and just type the country name and that's it. I will quickly get the details of country. Okay. But has it been listed? So what will happen is I need to now find out where Emma Watson is. Okay. Or where Elon Musk is. So I have to search or use it indexing factor the way we use index and match in Excel. So I have to find out and there I go here. So I've got the idea. It is in the first rank and because Power Query is zero based indexing, so I have to give here zero. Okay, so fetch the first name. And then the moment I do that, I have got the details. Okay, and how I have to figure out the country name, I have to give the second indexing. That is the country, the third in number. And that's how I get the you can say the value directly from the records or list. And if you understand this much about records and list, if you see this table again, this is a table, right? So how table works? So in a table, if I want to just get the yeah, I normally say this way, table is nothing but group of columns. Okay, group of columns in a list format, and a table is nothing but group of records in a rows format. Okay, so vertically you will have a group of lists coming together and they will create a table. And if you are working on horizontal manner, okay, so these are records. So the moment I click okay, I want to get the names here. So you can find here I will get the names quickly of everyone and then it will create a list. And if I want to fetch Elon Musk, then what I need to do is I need to type here the sixth value. So that's the thing you can quickly get. So this how normally people get confused when it comes to records and list. And that's one analogy of the buying music. It normally helps me to understand okay what is the which format I should follow to easily navigate the data. If I'm converting the data into records format, so it will be very much easier for me to navigate the data. So that's the thing. And I will tell again 1 second. So if you actually want to properly understand what are records and how many curly brackets and these are there. So I have prepared this after you can say writing so many queries and differences and you can see here. This is the curly bracket. Okay. So first, 1 second. Yeah, first you will be using curly brackets here, right? And you will be amazed when I will say you just see this way. I'm coming again, curly brackets projection. So here there is curly brackets to create the list, and then there is curly brackets to fetch those items. So I just talked about this fetching the item that we call projection. But yeah, we can do so many things with records and lists. And once you learn about structured data references, then it will be very much easier, because functions you can get any idea, but getting the value out of that particular thing, fetching the right value, is a big deal sometimes, and that creates a lot of problems, you can say, the nested structures and everything. So that's from my side.
Okay, thank you. Has anyone got any questions for Aditya? Aditya? No questions for now. If you think of any, put them in the chat, or send up a flare or something like that. There are no questions right now, so we're going to just move on. And I am going to talk about Power Query, not Power Query, Python. I'm going to talk about Python. Let me get myself orientated. Did I say that right? I've got too many files open. Right, yeah. Put that up there. Okay. So I'm going to just share with you straight away. There's no introduction, I'm afraid. Okay, so there's Excel. It's in dark mode, the way all things should be. And I wanted to talk to you about the Excel method. I can't see you all, but could you give me some visual indication of who has been working at all with Python and Excel? If you have, raise your hand. Or raise your hand physically, or raise it on the screen, on the tool. Okay, so some people. Okay, fine, good. So if you have used Python and Excel, then you know about this Excel method, and you know about it because when you create a Python cell equals py, press tab. This is the way I do it. And then once you're in a Python cell, you click somewhere and it creates these Excel calls in your Python cell. Okay. Now, but the thing about the Excel method is that it's in a Python cell, but it's not actually Python code, which is confusing, I think. The thing is that this reference needs to be resolved to the value that the reference contains before the script is sent to the runtime to execute. So this is passed by Excel desktop, converted into its containing value before it is then sent to the runtime to be executed. And because of that, you cannot pass a variable into the Excel method. You must pass a constant. So if you've ever run into that, that's why. But let's get to the point. I want to create a somewhat simple tool to create a report which I can filter. And I want to be able to filter my group by report, and I'm going to run it on some Python. I'm going to do it with Python on some data. Now, this data can be arbitrarily large, but for the sake of this demonstration, it's not going to be that big. So I've got a Power Query. It's called vSales. I think it's connected to the AdventureWorks database, the data warehouse version. So to connect to that, I can do Excel, open brackets, and press quotes, and it gives me a IntelliSense picker to select my query name. Control-Enter executes, and I forget how many rows are in this table, this query, but some. Let's see. About 60,000 rows. Okay, so I want to create a table which are going to contain the categories that I want to use to filter, to base my report on. So first I need to know what categories are available. So I can do df dot, I've forgotten whether it's capitalized or not. It's not capitalized. Okay, so remember, Python is case sensitive. df.category.unique. You can use this dot syntax like this when you don't have spaces in the column name. If you have spaces in the column name, you need to enclose the column name in square brackets and pass it as a string inside the square brackets. But if you don't have spaces, you can use dot syntax, which is why I avoid spaces. So this shows me that I've got 3 categories. This is perhaps not surprising to anybody who's used this database before. And I'm going to create a table, not like that, like this. And I'm going to just type my categories in because there's only a few there. Okay, and give it a name. Okay, so the next thing to do is to remind myself what the next thing to do is. Okay, so the first thing, I want to get the values that are in this table into Python so that I can use them to filter my data frame. Now, filtering on the 3 values is not going to do anything, but if I were to remove a row from that table, I would expect the filter that's applied to my data frame to reflect the removal of that row. So new Python cell, and I am going to do selected categories, and that will be categories, and I want the category column capitalized. And I don't want that actually. I just want the data, and I want to get the values. So putting dot values at the end of a data frame, where Excel returns a data frame in this case, putting dot values will convert it into a NumPy array. And by default, when you convert a data frame into a NumPy array, it creates a 2D array. So 1 column, 3 rows. I actually want a vector. So I want a 1D array. And to do that, you use flatten. So I now have a 3x1 ND array. Okay. If I didn't do that, it wouldn't be the same. I can't remember. Just add that now. Let's try it. I'm sure there was a reason for me doing that. I can't remember what it is right now, but I'm going to put it back because I think it's important. Okay. So the next thing I want to do is I want to create a mask to filter the data frame. And if you've used a filter function in Excel, then the include parameter, the second parameter of filter, is a Boolean array that is the same length as the array that you're filtering in the first parameter. It's called include in the filter function. It is also known as a mask. So I'm going to create a mask to pass to my data frame filtering. And that mask will be, again, df.category.isin selected categories. So I created that in the cell above. This will check every row, every value in the category column, and check if it's in that selected categories array that I created above. Okay, so that's now a series, and the series is, it's all true because it's all 3. Every category is in this table. Okay, fine. That's all simple. So another Python cell. So we can very, very quickly filter by just putting the mask into the data frame in the square brackets. We can use group by and pass the category column as the grouping field, and then sales amount, and then sum. That's a very simple group by function call. And that that works very similarly to the group by function in Excel. Hopefully you can see how similar it is. It's obviously all switched around, but it very much does the same thing. So what is the problem? Well, the problem is if I delete that, okay, that filters that. That's great. Yeah. And if I delete that, it filters it again, which is great. And if I put one back, it puts it back, which is great. Now, if I delete that, it kind of gives me just sale amount, which is okay, not great. But if I delete the rows, now I've got errors. Okay, and I've got errors because this call, you can see the error here. It says attribute error, none type object has no attribute values. And the reason is because this is referring to an empty column. So actually the return value of XL when it's an empty column is none type, not data frame. And because it's none type, it has no attribute values, and so it fails. So that's the problem. The problem is that when you're passing a column to this, it returns none type if there's nothing in it. Now I'm going to talk about how we can deal with that. So the first thing we can do is store. Let's do it in the Python editor. The first thing we can do is store the result of XL in a variable, and I've just called it XL result. Okay. Control Enter. Okay, that's no output, but that's fine. One second. And the next thing we want to do is we want to check if XL result is a data frame or not. And if it is a data frame, we want to do that stuff that we did before, which is values flatten. And if it's not a data frame, we just want to return whatever it returns as a list, even if the list contains the word none or the none type. So we can do that like this. So we can say selected categories, and instead of it just being the XL result dot values dot flatten, it will be XL result dot values dot flatten if is instance. And this is where we check if XL result is a data frame, like that. Otherwise, we'll just put XL result in square brackets to mean we'll put whatever it is into a list. And this is useful in this way because when you use the XL method, if you pass it a single cell or a named range that contains a single cell or references a single cell, it will return whatever the data type is of that cell. It won't return a data frame. So in this example, I always want it to return a list-like object. When I say list-like, an ND array is a list-like object. A list is a list-like object. A series is a list-like object. So in Python, they talk about list-like objects because they have iterable behavior and they can all be passed into similar functions. So doing that, I've now got a list that contains none because I have no categories. But if I put clothing and bikes in my table, over here, I now have an array that contains clothing and bikes. And because a list and an array are both list-like objects, they're both iterables, they can both be used to mask the data frame. Okay, so this is actually just needs to be copied down here. Okay, so now that's created that mask. And if I delete the rows, it's still creating the mask. But it's all false because it's comparing every category with the only element of this list, which is none type or none. Yeah. So you would expect when you delete the categories from the table for it to return no data. And that's what it's doing now. So you remove the rows and it messes up the report, but it doesn't throw an error. And that's the important thing. likes, and accessories. Okay, so this is kind of the point. I'm just going to copy this one because I just want to talk about functions a little bit. I copied this and I've just created a function called XL to list like, which accepts this one argument. The name is not important, and it just returns what we did in one of the previous cells, which is flatten it if it's a data frame, otherwise put it in a list and return it. This is a doc string. Interesting thing I learned today, or relearned today, is that in Python, any valid expression can be a statement. And that's the reason why doc strings can be just a string at the beginning of your function. They don't mess up, they don't do anything. Python just evaluates it and then discards the result if you don't assign it to a variable. So we use doc strings to document the functions. Typically you do it with 3 quotes and make it as detailed or as unhelpful as you want it to be. So that's my function, which is XL to list like. And now, in one final swing of copy and paste, instead of having the logic baked in to the page, this is of course pointing to the wrong sheet, but if I just delete that, that will make it easier to see. Instead of having to remember all this if is instance PD and which way round PD.dataframe and which way round the variable is in that is instance function, because I've wrapped it in this XL to list like, I can just wrap the XL method with my function and be sure that I'm always going to get an iterable in this selected categories variable, which can then be used to mask the category column and filter the data frame. So that was a lot of talking. I'm going to stop talking, stop sharing, look at the chat. Anybody got any questions or anything else you want to talk about? You see, was my audio really bad?
No, I can hear you loud and clear.
Okay. I kind of got the mic right in front of me. In the context of Jupyter Notebook in Python, there are code cells. Is it appropriate to say that each Py cell is equivalent to a Jupyter Notebook cell? Yes, I think it is. Definitely appropriate. You know, in fact, it behaves very, very similarly. You can even use IPython magic commands like %% time it to time your code. And always in a Python cell in Excel, always the last value in that cell, the last statement, whether it's an expression statement or an assignment statement, is always the output of your cell. So that's why I can just do this, and this is the output of this cell. It's a spilled array. Or alternatively, if I change it, it's actually a series. So that's it. That's my short presentation.
I just wanted to pitch in 2 random thoughts that came to me while you were saying it, Owen, which is just like for people who are used to Excel world and not used to Python world, like there's so much, like anytime you're used to one programming language and you start picking up another, it's jarring and everything is different and whatever. But one, as you mentioned in passing, is that that Python is case sensitive, as is Power Query, and that I've been using Power Query for years, and that still wrecks my head on a semi-regular basis. And, you know, I think real programmers think that we're just cowboys in Excel for not treating them as different. But anyway, that's the one. But the other one is the Excel function. It trips my Excel intuition up because you have your cell reference in quotes, very much like you would with an indirect in Excel, which makes it look like it's a string, not a reference, so that it wouldn't update if you insert rows or insert columns or other things like that. But actually, even though it's inside a string, it is also a reference and does move around or grow or shrink or whatever if you insert rows or insert columns and that kind of thing. So it's just, another little, this is not what you would think coming from an Excel background.
Absolutely. Yeah, the Excel method is just its own thing. It's how Excel integrates with the Python runtime. It's how you get data into your Python script. It's not really a Python function, so it has its own set of rules. And it's easier to just let someone tell you what the rules are rather than finding out in a very frustrating sequence of events. There's a hand raised. Dolapo, you're welcome to come off mute and ask a question if you've got a question, or if you haven't, then we'll just
I think
look
that
at
might
the
be a
raised
hand that hasn't come down since you asked about
right, Python experience. Yeah. Jose, do you have a question?
Yes, I'm sorry, my camera's not working, but I think, in my opinion, and just from what I've seen, is using Python. Obviously, you can do transformations using, Power Query. You can use Python. You can use Excel's native functions or what have you, right? But besides all of that, I think just personally, right, like forecasting, doing simulations using Python, right? Obviously, you can run like using like random like those Monte Carlo simulations or what have you, right? Have you seen that in your experience? Have you seen people leveraging like just the embedded Python to run those things besides transformations, given that the community at this point has basically adopted Power Query as the primary ETL tool? And it just doesn't, and I'm not saying it doesn't make sense to learn another tool, right? But just the learning curve that is Python for some of these users just doesn't at this point, you know what I mean?
No, I totally understand. And yes, I have seen people do it frequently. I tend to not present on those topics because that's not my expertise. And I think that the basics of transformations are instructive in learning how to utilize those other methods. So if you charge right into forecasting methods or into Monte Carlo simulations without having an understanding of masking or without having an understanding of data frame group by, you'll get frustrated quite quickly because you'll find that the data is not in the structure that the algorithm expects, and you won't want to go back to Power Query every time you need to make a small change. It's not to say that Power Query can't do it. It's just that it's not efficient to keep switching context. So my personal approach is to do the bulk of the transformations that I can think of or that makes sense in advance in Power Query to a level of granularity that will not restrict me when I'm taking it forward. And then if there are other transformations that need to be done to a data set for specific use cases, then they can be done in Python or with an Excel formula or whatever it may be. You can do pretty much anything you want to do with Power Query, but it does have that overhead of refreshing, which is not as dynamic as some other approaches. But if you want to learn more about like Monte Carlo simulations, George Mount is a good person to follow and see his blog post about doing that in Python and Excel. He's got some good material.
I will jump in, Owen, for one answering things thing. Like recently, we had got one challenge from obviously Excel BI. So he mentioned some of the, like, if I'm correct, not Excel BI or someone else, but yeah, about network networking days. Okay. So now Power Query doesn't have that function. So now how can I use it actually? So what can we do is, if you can do all those transformations into Power Query, because Power Query is user friendly, quite comparable to Python. And then what you can do is you can directly import the data from Power Query into Python, and then you can play around with it with that, you can say Panda, and it will quickly go with that custom business days. And it will be very easy compared to doing it in Power Query, making a custom function kind of that. Or obviously, if you just directly want to do the analysis, then obviously you can do in Excel. So right now what I'm doing is I am thinking a proper scenario, how can I integrate everything properly? Okay, I hope I'm getting bit off here, but yeah, what I mean is, so instead of directly, let's say, scraping data from Power Query, what can I do is I can scrape data from like Power Automate kind of way, then import the data with the help of SharePoint or in a way properly directly from Power Query, then do some transformations there, then take help from Python there, because Python won't load the data completely, then can load a particular data set after few transformation into Python, then load the data into Excel, and then I can do transformations there. So these technologies are opening so many futures instead of just relying on, okay, I am just going to use Excel. So instead of just relying on one tool, try to see in a way how can I integrate everything. So that's my perspective right now.
I think that makes a lot of sense. Thank you. I will not try to pronounce your name. I apologize, but the person with the first name, with the first hand up.
Yeah, I mean, you can call me as Reeve, that will be better. So my question is, for large enterprise level data where I am to pull data from different data sources, like different databases, maybe reports. In those cases, when I'm pulling the data and you can say the transformation activity I'm doing through Power Query. So in those cases, I mean, if I am to mix and match two data, I mean, checking one data source where I need to check certain field or certain attributes, and that has to be tallied with another data source's data. So in those cases, whether Power Query would be helpful, or is it mandatory if I go for a very full scale programming language like Python or R can be used in order to make the I mean, you can say the transformation activity, or PySpark instead. I mean, how do you suggest?
You can use Power Query for that. You can use Python. You can use R for all of those things. The route that you take will be dependent on a few things, I suppose. Familiarity, first of all, the rest of the tech stack, and the size and processing power that you have available to you. I'm not going to recommend that you try to process 100 million records in Excel. You can do it. I'm not going to recommend it because I don't think it will be very fast. If you try to do that on a Spark cluster, however, you could get it down to 30 seconds or less. So it really depends on the use case. It depends on how big the files are. It depends on how automated you want it to be. If the results of this tallying or these joins don't ever need to be inspected by eye, then there's really no need to bring them into Excel. Excel is a user interface for data.
I mean, actually, I had a scenario earlier where we had to ingest a big amount of data. Say, I mean, right now I could save 650 gig of data, but that cannot be definitely back in 2016. I'm talking about. Then Power Query was in its phase, but was not that helpful by that time. So I could not massage the data or transform the data in a very efficient way by that time. So I'm just thinking in those cases where we had to actually the data was one large big text file, and we split the data in multiple tables for querying, or you can say Hive-based table we created later on in order to show the transformation or make the data ready for the data scientists for further assistance. But in those cases, I found it quite challenging utilizing Power Query in the system because filtering and lots. I mean, it definitely get hung. I mean, I cannot do it because I cannot bring the data into my desktop to get the job done. So that was one of my challenges. I mean, if I large scale of data, if it's a large size of data, if I'm to do it through Power Query, I mean, what cautious step I need to make in order to utilize, or if I'm been compelled to do that. That's my question was.
Right. So a typical step when dealing with very, very large data sets will be to first cut it down to a manageable size before exploring the transformations that you need to perform. So sampling the data first, and then developing the transformations on the smaller data set, and then testing the transformations on increasingly large samples until you can transform the entire data set. The other thing to consider is paging the data. So if you've got 650 gigabytes of data, take the first 10 gigabytes, process that, take the next 10 gigabytes, and so on and so forth. You need to consider the amount of available memory, because if you try to do 650 gigabytes at once, you're going to have a bad time on a desktop computer. But in that example, I would probably do it with Python in a Jupyter notebook. I would not use Power Query for that.
Okay. Yeah, that's a clarity. That's a clarity.
Guys, 1 second. Hi. This is still awkward. I've encountered such issue. But one thing I was able to do, I think Power Query does this, is just segmenting or having clusters of data. And if you want to group it by year, so you could just capture a certain time range, January to December of 1 year, as long as you know a pattern of data set that you're getting is within a certain limit, and cascading them into like maybe 3 or 4 years, and of how you want to manage the data. So as long as it doesn't exceed that 1 million records, each data range, what I'm saying, it's like every year it could be under 1 million rows. So after doing that, it's just like he first explained, Owen, like you could just test it by little amounts of data first and kind of understanding the behavior, performance, and a bunch of other characteristics. And I mean, it worked fine for me. The only question I have was, after automating the process, I was no longer taking over that work anymore. So how do I hand over my access or privileges? I mean, is that a security thing that I can't transfer that application or process? I see you're mute. Yeah.
Oh, can someone mute themselves? I can hear traffic in the background. It's kind of distracting. So was that a question to me? Are you asking me like how would you, or is it more rhetorical?
The question is, for example, building this automated system with running data to Power Query, right? You have to own whoever initiates the whole model arrangement. Is it by the organization that you're running those systems on, or do you have to use the actual individual, the user building that system? Because, for example, I build a Power Query, whatever it is, report, and I automated the whole process, I'm trying to transfer whatever it is, the whole system, to someone else to take over. I wouldn't own that. Say, for example, my credentials are expunged. So who takes on that whole automated system? Can I transfer that system to someone else, or is it just lost? That's the question.
Yeah, I mean, I think that's an age-old question with moving in and out of data roles. And it all comes down to your coding style, your organizational style, and documentation, I suppose. That's my way of thinking about it anyway. You can make things very terse and very concise.
Yeah. Okay.
Yeah. If you make things I'm sorry.
Go ahead.
If you make things very concise and too concise, then it can be more difficult to read. If you make it too verbose, then it's more difficult to maintain. It's a matter of finding a balance. That's my opinion on that. But Eric has been patiently waiting with his hand raised, his digital hand raised. So let's hear from Eric.
Hey, Owen, thanks for doing this. This is great. I consider myself to be a couch level Python programmer. That means that I watch Dim's videos on the basics of Python and some of your videos and other YouTube videos, but my actual experience typing Python into cells or Jupyter notebooks is fairly limited. So what I do in this sort of situation is I rely on our friend ChatGPT to write Python. And it actually does a very good job at writing Python in general, and I have used Python from ChatGPT. My question is, how successful have you or anybody been in using ChatGPT to write Python that is specifically geared towards being used in the py function in Excel? Because I know that it's a limited set of packages that it has availability, and there's certain syntaxes, and at the end you return back the value that you want to return in a way that isn't really how you would do it when you write a regular regular Python code. So what advice do you have for us couch potato Python programmers?
So I have some experience with that, and some time ago, I can't remember how long, but a while back, a year maybe, I wrote a post on LinkedIn which described and listed a set of custom instructions to put into ChatGPT to describe Python and Excel and how it works to ChatGPT, so that when I'm talking with it, it can refer to those instructions and give me relevant code that works. So you can use custom instructions is one thing you can do. I've actually found that I can share it with you. Actually, somebody asked me about it just a few days ago, and I had totally forgotten I'd written it. And they said, "Do you remember this post that you made about telling ChatGPT to use Python and Excel?" And it sparked the light bulb, and I found it, and I can share it with you as well. I have found recently that ChatGPT is now better with Python and Excel, but it still does sometimes recommend libraries that aren't present. The most success I've had is with Claude. If anybody has used Claude for Python coding, is very competent. And the great thing about Claude is that you can create projects, and in the projects you can add documents. So I have a Claude project for Python and Excel, and I have added a text document in there with a list of the packages that are available. And I've added another document in there that describes how the Excel function works, and another document that describes how a Python cell works, how it returns data to the grid, what Python output mode is, what Excel values means, what Python object output mode means, and so on and so forth. So it's kind of like an advanced way of managing context for your chat. And that has been the most successful I've been with an LLM when it comes to writing Python and Excel code. But I think the custom instructions work quite well. So I will share it with you. And
awesome.
Darren says ChatGPT just introduced projects. So that's great. Projects are super, super useful. Does that answer your question?
Yeah, that was super helpful. Thank you very much.
Great. I just want to scan back over.
Owen, I will add one more point there. If you are like completely focusing on just like only one Python in Excel, then what you can do is you can make your custom GPT as well.
Oh,
so it will also help. It will also help. That's what I wanted to add.
Yep. Now, Copilot in Excel, the advanced analysis feature, which creates Python code, is pretty good at getting it right as well. Sometimes, even with the custom instructions, ChatGPT will put a bit of extra code at the bottom of the snippet that it gives you for displaying the values to you. Even when you explicitly say the last value is what is displayed, the last statement is what is displayed. To display the data frame, you just put the data frame name in the last line. That's all you need to do. And sometimes it will still put extra code and import a weird display library that nobody needs. But Copilot doesn't do that. So Copilot is actually pretty good in lots of situations. I think there's still room for improvement, but it's getting better. It's my opinion. I just wanted to cover some of these questions that I saw. It was actually only one or two, maybe. Ismail asked about data size limit. You can only pass 100 megabytes of data into the Excel method. So that's either fewer rows or fewer columns, or less complicated columns or less complicated rows. So if you find yourself with a big Power Query and you've got a bunch of columns in there, and you look at those columns in Power Query and you say to yourself, well, I'm never going to need that. I will never use that 26-digit character skew, or I'm never going to use that globally unique identifier. It is best to just get rid of it in Power Query, because those big long strings are what will cause the problems. So I say 100 megabytes is not the limit of sending data to Python in a workbook. It's the limit for one call to the Excel method. So you can have several calls and call it several times and send up many, many hundreds of megabytes, but you will find that performance gets pretty bad.
Yeah, actually, I'm concerned about the performance, because when we are uploading the data, it's a two-way communication. So I'm sending the data and receiving the final data. So if it's in larger size, then it will take more time to upload the data and then get back the response, right?
Yeah, for sure. Yeah. There is caching that happens. So you may have noticed when I execute some of these cells, if I execute this one, you'll notice that all the cells on the sheet re-execute. Yeah, that's the default behavior. You can change it by changing the calculation mode. I'm not sharing with you anymore. That's why you can't see what I'm doing. You can change it by changing the calculation mode, and that is in the normal place. If you change it to manual, then of course you can make as many changes as you want and then just re-execute it once. I believe partial is only available if you're paying for the premium compute, which is the monthly subscription to Python and Excel. And then manual, of course, is manual, but you need to be careful with that. I always leave it on automatic. So the reason I brought this up is because although I've got this call to Excel here, which is loading my 60,000 rows, if I have done that previously, there will be a cached version of that data, and it won't necessarily refresh it every single time if it doesn't need to. I don't know exactly how it works, but there is caching that happens. Okay.
Okay.
Yeah, go on.
Yeah, each cell in the Python is a separate instance of, let me rephrase my question. I mean, in Excel, when we execute the Python command, so each cell of the Excel is a separate instance of the Python, right? We can make separate instance. And it is not getting mixed up, or will it get mixed up somehow?
So each Python cell is sent to the same Azure container and the same runtime. So all of the variables that you define in the Python cells in your workbook are in the same scope. In Python terms, they're all in the global scope. So that's why I can define the data frame in cell B2, and then I can reference it in cell B4, because these are both in the same scope. Okay, so it's not creating a different instance of Python. They're all in the same instance. They're just separate cells.
Yeah, thank you for the clarity, because I had a misconception on this earlier.
Okay,
Thank
it's
you for the
okay.
clarity.
Okay, so I think we're coming to the end of the meetup, I should say. I really appreciate Ismail. Have you got another question?
Yeah, so like, in data frame, we have some method that has an in place, property, and if we set that to true, right? Like, we have a data frame in P2, and then maybe in C3 or C4, we have that in place to true. In that case, no, it's overwriting that B2, right? Like, it's modifying that B2 cell.
Yeah.
Okay.
Yeah, that's the difference between, that's a very good point. That is the difference between because it's a reference to the data frame. It's not a copy of the data frame when you make that change. So even if the definition of the data frame is in a previous cell in the calculation order, after the in place call is executed, then if you were to place after the in place call is executed, df is changed wherever it appears, even if it's before. It's kind of irrelevant because you can't then go back and write code between the in place call and the definition of the data frame and execute that code without all of the rest of the chain executing as well. So in that case, the new code gets executed before the in place call anyway. But that's part of the reason why they all execute every time, is because of that. So yeah, I really appreciate everybody coming along. It was the first meetup. It was very short notice, only 2 weeks notice. I am going to try and do an in-person meetup in Colorado in January, and then another online meetup in February. If I find that monthly just isn't enough, which is doubtful, I may schedule them more frequently, but I'm just finding my way. So I appreciate your patience and understanding and coming along to chat with us about this kind of thing. Thank you. I'm going to stop the recording if I know how, which I don't. Stop recording. Okay.